Thank you very much. I'm very pleased to be here to discuss about one of the latest point in time in relation to the SSbD decision process. And we are now discussing about the integration of the different aspects that has been assessed and discussed so far. Indeed, in the last day, we have been discussing about safety aspects, sustainability, social, economic, environmental sustainability, and now we are in a moment where we need to combine all this information, if possible, integrate this information in order to support the decision analysis. We need indeed to decide if a specific material or product can go on in the development or should be stopped. In this presentation, I will frame a little bit the problem, while later on, Alex and Massimo will go in more details into the methodologies for decision analysis and in the tools that are available now to perform this kind of assessment. We have been all taught about the latest development of the SSbD framework, especially in the first day of the school. Here I would like just to underline three important key aspects that can support the understanding of this presentation, and it is the fact that the SSbD framework is a tiered and iterative approach. It goes along the life cycle stages of chemical and materials, and it covers all the different development steps with a specific focus on the early stage of innovation, because it is there where you can identify possible hotspot, you can already take some measure to optimize or modify the material or the product without incurring in additional or too much costs. Here we have the general scheme that has been provided within the methodological guidance, where you have the different level of assessment that are included within the SSbD framework. We have been talking about the scoping analysis, especially in the first day of the school, that has been introduced by Ilancio and also by Martin, where we have the initial system definition, the identification of the actors along the value chain, and the four important questions, that is why, what, who, and how I need to perform SSbD assessment. Later on, according to the data availability and according to the stage of development of the material or chemical under assessment, you have different level of assessment. There is an initial one that is a simplified, that has as objective the fact of the identification of hotspotable concern, but also the evaluation of a higher number of alternatives in order also to kill those that are not performing well, because this means save cost. As soon as I kill an innovation that is not providing the right functionality or the right safety and sustainability performance, I'm going to save cost. Later on, when the process is, the product or the material is in a later stage of development, I can have more sophisticated assessment that could be, for example, semi-quantitative assessment that can support the identification of the safety and sustainability performance, but also they are used to check if the concern identified in the previous step, in the previous tier, have been addressed. Later on, we have the integration of safety and sustainability impacts in order to give a final full SSbD assessment. We need to underline that this is a simplified scheme that should not be seen as a strict way to see the process, but more as a flexible scheme, because we need to consider that there are natural overlapping and transition between the different tiers, depending also on the data availability and the innovation stage of our product, material, or chemicals under assessment. Following this general scheme within Sunrise, we are developing an integrated impact assessment approach that is composed of different tiers. The first tier, that is divided in two sub-tiers, is the qualitative tier, where the first objective is to support the decision makers in understanding among a relatively high number of alternatives those that have the higher performance in terms of functionality, safety and sustainability. In this first part, functionality plays a key role because we do not want to go on in the development with alternatives that do not meet the minimum functionality requirements. Once we have a, let's say, decreased number of alternatives, we can use a other tier that is always also qualitative assessment, but it is composed of more questions that go more into details in the assessment, and this can support the identification of additional spots, but especially of data gaps, because we need to identify which information we need to go on with the assessment. And for this reason, this can also support the identification of the costs that need to be incurred to go on with the development. As I said before, this is also the moment where we should identify those alternatives that need to be stopped. Later on, when the material and or the chemical is following a further development, we can use screening assessment tools that are semi-quantitative, that can assess safety and sustainability performance in order to check if the identifying concern in Tier 1 has been addressed. And finally, we have the Tier 3, that is a quantitative analysis that can be performed in the later stage of development, where the data available can support a quantitative assessment. And in this case, it follows the regulatory risk assessment path, but also we can use tools such as life cycle assessment, life cycle costing, social LCA, that can give a quantitative assessment of the sustainability, safety, performance of the alternatives. All these tiers are aligned with the stage gate approach and need also to be aligned with the 5 steps of the GRC framework. Going a little bit more into details about the integrated impact assessment approach and how it is composed, that is what we are developing within Sunrise. We can see it like a tree structure, where we have at the top the different steps of the GRC framework. We have sum up, let's say, a little bit the first 3 steps, because it's the part related to safety, and we have also divided step 5A, that is social, from step 5B, that is economic, just to give more focus on these two. And for each of them, we can identify specific indicators that need to be measured using experimental methods or tools. Now comes the need to develop methodologies to integrate this aspect. And this integration can be done both at indicator level, but also at the higher level, considering the different steps of the GRC framework. When we speak about multi-criteria decision analysis, we intend to include the possibility to account for stakeholder perspectives, for giving the opportunity to consider, for example, if there are trade-offs, if we can identify specific weights that are also related to stakeholder profiles, in order to give different importance to the indicators that we are assessing, but also at a higher level when we are discussing about the integration of the different steps. This is because in some cases we could have conflicting objectives that need to be deal with by using also the involvement of stakeholders. Here I would like to bring some example on how it means, what it means to integrate the different indicators in order to support the decision making. This is the web page where that includes the Tier 1 assessment, where on the, I don't know if, yes, on this side you can have the different aspects that can be assessed. That means functionality, safety, environmental sustainability, social and economic sustainability. For each of these aspects, you can see the different life cycle stages that have been assessed, and for each life cycle stages you have different questions. The user is asked to reply to this question, and at the end, as a result, you can see the comparison between the innovative material and, in this case, in gray, the benchmark, in order to understand how the innovative material performs in comparison with the benchmark. In this case, we have just two alternatives, but this can be done also for more alternatives. This can support the identification of possible hotspots that need to be further assessment in the later stage of assessment. And finally, you can have also a final assessment that can indicate if the innovative material is performing better or worse than the benchmark. Some take-home messages in relation to this. We have been discussing during these days that the SSbD framework has the main aim to support the decision-making process along the entire innovation path, and it uses different assessment levels that are depending on the research and development stages that are under assessment, the objective of the SSbD assessment that can change according to the development stage of the material product, and especially the data availability, because data availability is one of really the key point and challenge when performing SSbD assessment. At each assessment level, at each tier, there is the need to develop methodologies to integrate the result coming from safety, environmental sustainability, social sustainability, and economic sustainability in order to support the comparison of alternatives, but also to support the decision if a material or a chemical respect, let's say, the SSbD approach. And finally, there is this important aspect of the inclusion of stakeholder perspective profile, because this can change the integration approach, this can change the final result of the assessment, because they can have different trade-off among the different aspects that are assessed, and this is really important and need to be further discussed and further researched during our project, but in general. And with this, I can leave the floor if there are any questions.
So we will continue with the last topic before I think that after this is a coffee break. So the last topic is multidimensional analysis on decision-making tools. We have two speakers, Zabeo from GreenDecision and Massimo Perucca. I don't know who is going to be first. You go first? You go first? Alex. Okay, so yeah. So Zabeo from GreenDecision.
Okay, thank you. I'm Zabeo, working in Green Decisions with Lisa Pizzol, and I will just introduce to you multi-criteria decision analysis in a very friendly way, I hope. Of course, I forgot to change the subtitle, but it's okay. So let's move on. So I'm Zabeo, but this is not interesting. I'm just here to say that I work with a lot of staff for different projects, and especially on MCDA applications in the field of safety, in most of the cases. So the first question is, why does multi-criteria decision analysis exist at all? So we take decisions every day, and everything works. So Homer wants to cut the tree because it shades the house, but of course it was a wrong decision. So you need to think about things that you do, because we tend to make wrong decisions. So in fact, we are very bad in taking complex decisions, if not aided. So we usually base on intuition and experience. And so I suggest you to take a look at this nice video from Dan Gilbert. It's an old video, but it's still good to see. Dan himself, he was he wanted to be a writer, so he went to the university to sign in as a writer, but then there was no place for him, so he had to go and change his mind. He went to psychology, and then he became one of the most famous in the field. So sometimes you also need to be lucky. That's it. So anyways, so I ask you, would you pay 25 euros for a Coke? I don't know where you live, but even in Norway, I don't think you will pay that. So no way. Maybe for a beer, almost, we're close. Maybe Homer can think about it, but still no. But then if we change the conditions, the decision changes. So again, we always base on our previous thoughts and our standard conditions. We need to think more deeply, especially in complex problems. So this is one case where you don't want. So we need to structure the decision, which means creating a set of rules and a set of organizations that help us in taking decisions. So when we structure a decision, we get a lot of benefits. So we are objective, so we do things the right way, let's say. We decrease the uncertainty, of course. We allow repeatability, which is important. Maybe you have to buy a phone, you create some kind of structure to decide how much memory and which kind of monitor and things. And then after some time, your son or you want to change the phone again, well, you can repeat the process if you build it in the right way. It fosters transparency, so it means if you are deciding for a group of people, then you should be transparent on your decision, otherwise you might get some not nice reactions. It simplifies group decisions, of course, because then you have a tool that everyone can share and take the decision all together. And it forces coherence. This is an interesting point, in my opinion, because we always think we are coherent, but we are not always coherent. So I would like to give you this challenge, and I would like to have one person trying to take this bet. So we have an urn with 90 balls, 30 of them are red, the other 60 are mixed of yellow and black. So you don't know how many yellow and how many black. And you can buy two different tickets. Ticket A, you receive 100 euro if you draw a red ball. Ticket B, you receive 100 euro if you draw a black ball. So I don't know. Who would go for ticket A? Very good. Who would go for ticket B? Very good. So we can see most of us, goes for ticket A. I would also buy ticket A. But then we change a bit the bet. So the urn is the same, the balls are the same. But I propose you a different way to bet. So you get 100 euros if you draw a red or yellow ball, and 100 euros if you draw a yellow or black ball. and the conditions are the same. So how many of you would stay with the bet A? Okay, how many would switch to bet B? So again, luckily, it worked. So you notice most of us, me included, would have changed bet to bet B. Okay? But let's see, have we been coherent? So these are the two bets. So in the first bet, we went for A. It means we believe in that moment, because we didn't go for black. It means we thought inherently that there are more yellow balls than black balls. Otherwise, you would have bet on the black balls. But in the second case, we bet on black and yellow, but because yellow is the same amount, then we are saying we are not, we are going for the black, but beforehand we said, because the orange ones are exactly 30, so if we go for the black, it means we think there are more blacks than orange, it means there are more blacks than yellow, it means we didn't follow the same logic as the first bet. So we didn't notice this, because we just went, what we did, all of us, is we went for the thing that was more known. We had more information. In the first bet, we know exactly there were 30 orange balls, so we went for that. In the second bet, we knew exactly there are 60 in total, so we went for that. But it's not always the case that we think in the right way. So having a tool and a structured decision help us avoiding these coherence problems that you don't even notice. So how do we structure the decision? Well, there are a series of steps. Let me check the time. A series of steps we need to follow. So we first understand the problem, select the alternatives, the criteria, we quantify, define decision makers, etc. Let's see these points. So let's say that Homer has a problem. He has a not nice hive of I don't know, bees, let's say, and he wants to get rid of it, of course. So first step, understand the problem. So these are hornets, sorry. So strange for him, but he should go and search for that. Maybe he's allergic to hornets, then this makes the problem a bit more complex to deal with. Maybe not, but he needs to know what he's dealing with. Then he should select alternatives. So what should he do to get rid of it? So he should tear down the wall of the house, and the hive is gone. He can smash the hive, and it would be nice, probably. He can set it on fire, of course. Or he can smoke them, and they fly away, boring, but might work. So now he has different alternatives to select, and he needs to choose a way to decide. So you need to select criteria. So how do I value my different alternatives so that I can then choose? It can be time, feasibility, cost. There are several ways. It's okay, but I can measure time in hours. I can measure costs in euros, but I cannot measure feasibility, which is a concept, basically. So what should I do? Well, in this case, I apply indicators. So feasibility, it's okay, is there a place that sells the stuff that I need? Do I know someone who's an expert? So I can translate this to something more measurable. Then define the decision maker, well, because in this case, if it was for Homer, no decision analysis at all, we just tear down the wall and that's it, but he lives in a family and probably he's not the main decision maker, but at least it's a group decision. So they need to agree on something. And so now they need to elicit their preferences. So what is the most important thing you should look at when you're dealing? So because the decision on alternatives is not the same for all of us. So Homer wants it funny and regardless of cost, while Marge wants it cheap and safe, of course. So they are not agreeing at all. But once they have their preferences, they have the alternatives, they have the criteria, they can apply a decision process. Because they structure the decision, they can apply math. This is random math, just to say, you apply something, and this gives you a ranking or a selection or a solution, And so this is a ranking, and in the end, as you would have guessed, we can smoke the hornets and get rid of them without destroying the house or risking to be, I don't remember, anyway. Get punctured, thank you. So this is okay. So let's go a bit in a more boring stuff, but anyways, how does MCDA works? There are different methodologies to aid decisions when multiple criteria are involved. Anyways, you always have alternatives, criteria, and preferences, and then you take the decision. This is the official definition. I just want to say this thing is not exactly in the same position, but anyway, there are some parts that are the same for every method you use, so the way that you evaluate, select the alternatives, the criteria, and the preferences. What it changes exactly is the way that you apply math to decide what to do. And this has implications and consequences on the result. So the method changes the result in some cases, so you need to be aware of what you're doing. So a simple example, just to give you an idea of what happens, is you can have a decision matrix like this one. Then you have different criteria for your alternatives. You put in the values where you have them. You might have empty spots somewhere. You need to deal with that. So you can see that alternatives are just labels that you put to data. Then you should, I don't know how much, we should finish at 10:30, right?
No, actually, you can speed up a little bit.
I speed up. So just this one is interesting. So you organize your criteria in a tree so that you can aggregate step by step in order to get to the last point, because otherwise it's too complex. You need to normalize data, and todo necio confunde valori prezio. So it's not that the money is always the right way to evaluate things, especially in the environment, for example. You apply different aggregation functions to your steps, and then you get the results. I don't want to go into this. There is an error, but you can check the slides afterwards and see if you can find it. So remember that MCDA is just a tool and not a decision maker. So you apply the tool, you see the results, you think about it, and then you decide if you want to apply or not the results. That's it. I just ask you to remember to go and scan the QR code for the questionnaire about, I have it here, I'll just show you, because it's from the Sunshine Project. So in the entrance you will find this, just scan it and do it. Thank you.
And now is the turn from Massimo Perucca from the Project Hub 360. So if you can also speed up, that would be great.
If we can change the screen, yeah, thank you. So thank you, Alex, for your presentation. I just don't agree on one slide that the team decision was on the right, the wife. Yes, thank you. So, okay, this is the presentation indeed, but since the time is little, so I try to change a bit real time. And to dive into some specific example of MTDA, I would like to introduce briefly with some points that have been already somehow treated before. I want to highlight the point that SSbD implies multidimensionality. Okay. I will provide you some features and advantages of the methodology that we propose to implement the framework. And I will stick directly to some multi-optimization example together, real time, okay? So, this we know, we have different dimensions. Sustainability is environmental sustainability, social sustainability, economic sustainability, safety is in reducing toxicity exposure, etc. And we also learned that functionality is the basis of all this, because if there is no functionality, there is no case study, there is no business case, there is nothing. Okay? So very important, the first part of the morning session. So why should we have a quantitative approach? Scoring is quantitative as well, because we want to reduce the level of arbitrariness in decision making. We want to refer to robust and acknowledged reference levels, if are there, to low ordering and ranking of solutions. Is it possible to quantify? Yes, it is, we will see. And why? Because this will allow a clearer and better comparison made on same comparative base. We have to be case specific to deal with representative data, representative numbers. Okay, but in R&D or RTD, research and development, there are some hurdles. So this is the main problem of, say, fair data or availability of fair data or availability of data at all. So data are expensive, need cost, time, resources, and when we are starting in new research, most of the time we don't have enough data. So in order to make SSbD applicable to R&D framework and responsible innovation exploitation of resources, time and cost should be reduced to a minimum and sufficient level in order to extract information. Advantages and requirements of the proposed methodology. So let's see some feature and advantage. So quantitative base, we have seen, we can compare, we can measure, we can rank. Case specific, we deal with data which we know what they are representing. We can support this process with the decision support tools. There are many. We are proposing one of the many options. And this tool is able to capture non-linearities, so the behavior of the system based on different design options. And moreover, for scientists, it's quite important to relate multi-performance design options and to physical-chemical features of the materials being developed. So this provides indications on how to proceed in the next research, challenges. So each design option is associated to a multi-performance profile with the solution, and this multi-performance profile is dependent on the physical-chemical features of the material produced or the synthesis applied. Important to say that we are promoting a holistic and multidimensional approach. We have seen in the functionality, just one dimension functionality is already enough complex to deal with. We have to have a holistic perspective to consider all the details of the case study, the functionality, the use case, and the use condition, the operating conditions of components and materials. Important to say that incorporation of a stakeholders profile is key, because of course we have to make those solutions acceptable, compliant with regulations, and also competitive and advantageous for different stakeholders, like the producer or the stakeholders who commercialize the solution, for instance. Finally, how to deal with all this complexity. The DST will reduce the complexity and provide a clearer picture, synthetic picture, allowing stakeholders, humans, to finally decide which is the best, safe and sustainable by design solution, based on criteria and preferences, of course. Another important thing is that we have to tackle complexity through modularity, and this result, and this requires, recalling EuMINE presentation yesterday, harmonized data set, fair and harmonized data set. So, important to say that this approach implies the definition of key decision factors, which are design options, and key performance indicators. It's important to design the right key decision factors to render the problem treatable. And this scales, of course, exponentially. So let's dive into a specific case study. Then we can make some comments. So this is one of the dragon being defeated case. This is taken from the antibacterial case study. You see an harmonized data set. We have two key decision factors, which are two reagents in a formulation to be assessed. And those data are, sorry, those options are referring to all the dimensions. So the antibacterial level with respect to different bacterial strains, Escherichia coli and Staphylococcus aureus. We have got all the environmental impact categories responses related to the formulation. We have got experimental data related to the cytotoxicity. Recently, with the help of Sarah, thank you Sarah, we got also scoring social impacts. We do have cost impacts, but these data are referring to what? Just to the synthesis process. So we are referring to the technical unit, amount of 30 milliliters hydrogel produced. And let's see what is the results. We are running this. I prepared this simplified model for you. And so we are computing with, well, not too deep analysis because the time would be too much. So we are here representing the performance space. Maybe I can enlarge a bit. The performance space provides you, each point is referring to a level of antibacterial activity on the x-axis. On the y-axis you have the cytotoxicity here, and on the z-axis you have the, the z-axis is the cytotoxicity, and you have cost on the y-axis. Here you have social impacts on the z-axis, and here you have climate change, which is representing the environmental impact. So you may choose among those options. Those are multi-optimal options. No other option than those would be selected by any stakeholder with specific preference. So the system simplifies a lot the decision on which performances or multi-performances we can afford with this case. But, well, once we define what is the point, we will need to find out the synthesis, right, formulation. And this is the decision space. So each point on the boxes up there are referring to a specific option in the formulation that you can choose that will lead to that result. This implies, of course, a human-centric process, which is this one. Sorry. We do have the performance space. We have many stakeholders here discussing, arguing, okay, and finally they get to an agreement to select one specific point. And this will lead, of course, to the final solution. But let's see, consider just here in the set we consider the production of 30 milliliters, but what is the yield of the process? We produce 30 milliliters, but we produce 30 milliliters if the yield is lower than 100%, then we need to take into account the yield in order to assess, for instance, the impacts associated to this increased amount of reagents to get 30 milliliters of hydrogel. And the results will be straightforward computed here. Let's go to the software. The MCDA algorithm is thinking a bit, and then you see it provides a totally different output. The options that are suggested are totally different because you consider one more factor, as Alex was saying before. So it's important to frame the case study in the right way. And here is the scattered set of points. And if you want to have a high level of, say, toxicity parameters, which means low toxicity in this case, you want to go in that region. But that region is representing low antibacterial activity, which you can achieve with this formulation. And if you want to be there, it means that the climate change is also increasing. So you have to negotiate. That's why the human-centric negotiation phase is important. But based on a simplified set of solutions, you argue on specific objective solutions. Now we want to incorporate this material onto a fabric, and let's see what happens if we go to the incorporation phase. Okay, this is the DOE metrics you've seen here. So these are the points in the DOE, and we run this, in which of course we take into account the yield. We want to disregard the amount of deposited material. So we think that we can run the case and let's see what we obtain in terms of options. Okay, this is the other model. Taking into account the first life cycle stage of synthesis, and then we add on top of this the incorporation sub-case study. So we are following the life cycle of the material. And in this case, we see that the different options provide this different picture as well. You see that the points are less scattered. We are addressing more and more, let's say, constraint or features to our case study. Now we want to, for instance, consider the real amount of deposited materials on the fabric. Yes. And, sorry, you should have set to 0, to 1 here. Let's run it again. Yeah, we are done, yes. Okay. And we see what's going on. It's thinking a bit. Yes, hopefully we'll arrive to the final result. Here we are. And we see that still, taking into account the amount of material deposited, the options are different. Here are the reduced number of cases. And then finally, you can consider the use phase and say, okay, how many washing cycles the fabric will keep the level of antibacterial activity to have an antibacterial fabric along the use phase. And you can take this into account. 50 seconds we do have. So let's show that. Take into account the washing cycles according to the different design options are here. The use phase provides this. And here we go. You recognize some of the formulas of Alex. It's more or less a lot of maths, but yeah, here we are. So you see still another completely different profile of options. These are the only options if we select the specific stakeholder profiles, okay? And that's it. So we may choose. I will not choose now because we should entail arguments, and there is no wife here, so we cannot decide, I think. It's all the husband. And finally, so I'll get to the conclusions, not to get you bored. So we were here. Let's go for the take-home messages. And it's just one slide, so we can make it without. Okay, so data-driven. Data, I reply, this it may be also scoring, yes. Case-specific, we have to measure in the lab to model specific conditions. We can use this multi-level stage, considering and analyzing life cycle stages in a sequence to get the problem solvable. We can challenge it. Yeah, there are requirements anyway. This is not for free. We need a minimum and sufficient number of data points. So 6 experiments with replica are enough to assess what is the best formulation according to different criteria. And we need the harmonized data set. So don't forget Iri. She is the shepherd. Then data covering all functional, environmental, social, economic, and safety dimensions are needed. And within the dimension, we need to define suitable KPIs representing what is sustainable, what is safe, what is socially having positive or negative impacts. What are the total advantages? Okay, the SSbD, as it is, as such, it reduces the risk of industrial development and produces advanced assessment of industrial and commercial exploitable solutions. So company will never go for any SSbD costly and time-consuming process if they are not somehow, if they don't have the payback of certainty or say a high probability of getting the product into the market and commercializing it. So we need some methodology which is useful, fast, and cost-effective. Minimum number of experiments is the translation of those requirements, and the decision support systems that enable you to simplify the computation of a huge amount of data in data sets that cannot be worked out by hand, of course. Thank you so much. I think that we are on time, and the coffee break is waiting for us. Thank you.